Hey everybody, we are back. Today we are revisiting our Ultra X4 power supply. Now that we've got the proper resistor kit, we can actually see if we can get this one fixed and working again, which is my big hope. Definitely would love to see this back in the case it came out of and powering the system. I actually bought that Ryzen processor for, which was featured in the same short. We'll start by taking out the top screws here. Obviously on newer power supplies, they have stickers on them that say, if you break this sticker, the warranty is voided. Well, you have to be the original purchasing party to be eligible for that warranty. So in my case, doesn't matter because, well, the warranty was already voided. So no big deal. The biggest thing to look out for on these power supplies is, they don't always have an obvious break point. In the previous video I did on this one, I was thinking that it was a improper solder patch that I tried to soak up some extra solder from, which, could have had something to do with it. I thought maybe it was grounding out against the case. However, as I was struggling to get that to do anything for me, unfortunately, I found that that probably wasn't our problem because there was a resistor on the board, which I'll have to relocate again here, right below this heatsink that apparently had a pop to it. It looked like it had been overloaded, and that would be an obvious point of failure on a power supply. Other things you can look for, blown capacitors, certainly on older power supplies was very, very common. Once you kind of get past the obvious, something burnt, something broken, something exploded, then you actually have to go through and start testing original components to see if, they're carrying the proper voltages, and it gets a bit more technical from there, and to be quite honest, is a little beyond even perhaps my expertise. I'm not an electronics expert by any stretch, but I have a multimeter and I can typically figure out how to read it. There are plenty of how-to videos out there for restoring an old power supply that doesn't work. To be honest with you, there are so many power supplies in junkyards and recyclers that if you really need a replacement, you're almost better off just going to your local recycler and seeing if you can buy one. A lot of the times they have so many and they don't make a ton of money on salvaging these that you can probably pick one up for free or cheap. So keep that in mind. If, however, you don't have the luxury of a local recycler or a recycler that'll sell things to you, fixing these is typically fairly simple. And again, a lot of the times you're looking for a bad cap or a blown resistor, and those can be very, very easily fixed. Cap kits, resistor kits are fairly inexpensive. This one was less than $15. The cap kit I got was around the same price. So typically they come with like 100 to 1,000 pieces, and you can get a whole smattering of anything you may need. Now, the thing to remember about capacitors is you have to match the resistance, but the voltage should go up as much as you want. So if I got that wrong, somebody please correct me, because I know it's the voltage you can always go up on, but the other numbers need to match. I think it's resistance. Maybe it's probably capacitance now that I'm saying this out loud. So if you don't have an exact matching cap is what I'm trying to say, you can actually use a different capacitor in its place. Some of these bigger ones, obviously you have to try and get, something that has the same numbers on it. Again, the voltage can be different, but you want to make sure to get an appropriate capacitor. Otherwise, when you plug it in and try to fire it up, it's just going to blow up again. So that being said, let's find our dead resistor and see if we can get good access to it. If we can, we'll go ahead and take our soldering iron, desolder it, and get the new resistor in place. If we can't get good access, we'll have to do a little more teardown. Okay, so I located the resistor. It's right down here. You can see it's right next to this heatsink. The tough part about this is the heatsink's anchored on the side right next to this capacitor. I should be able to take the main board out. There's only 4 screws. The only problem is this wiring harness is all soldered into place. and it's got this stupid little zip tie here. However, once the board is out, I should have good backside access to basically heat that resistor pad up and pull it out. I can probably get a needle nose in there. Oh yeah, well enough anyway to get access to it, but resistors usually come out pretty easy, and then once that's out, I can kind of finagle one back in its place. I'd like to keep it as tight to the board as I can, but if it ends up being a little bit higher set than the old resistor, it's not a deal breaker either. I'm going to do just a little bit more close examination just to see if there's anything else going on, but again, I don't see any blown capacitors or anything else obvious, so I'm still pretty well convinced that that is our culprit. I do think, just for ease of access, we're going to cut this little zip tie and get that out of there. I'm not a fan of zip ties. I know my cable management, you've probably seen in other videos, is not the best, but I think zip ties are just a terrible way of managing cables. I know why they did it here, because this really isn't meant to be opened by the end user, but if you're restoring something, make it your own, so that way, if you did need to go back in here, it wouldn't be that big of a deal. Now, it is kind of a big deal to try and keep your harness out of the way, but in all honesty, this isn't going to be something that's going to get a huge heavy draw all the time that we're going to need to worry about that too much. So let's go ahead and snap that and pull this main board out, and hopefully we'll have enough access at that point to go ahead and take that old resistor out. Okay, so unfortunately, this is kind of the best we can do with the way this is wired together, but we've got enough access. So the pins right there, those two in a line, that is our resistor. And looking at the back side of the board here, I don't see any other points of obvious failure. So my hope is once we get that to heat up, we can probably just pull it. I think the tough part is going to be actually getting it pulled and then having the ability to drop one in there. The bummer is to get these damn heat sinks out of the way. To get any other kind of access, we'd almost have to tear this whole thing apart. And at that point, I don't know that it's going to be very simple or worthwhile. But we're going to go ahead and give it a shot. I'm going to just kind of set this up a little bit so it's a little easier to access, and kind of restrict this plastic back here, this guard, and see if I can wedge something in here to kind of give us a little bit less play and slop. This is where I'm hoping that my little soldering stand can help me out and at least give me a little bit more flexibility with when I'm actually working on this. And of course, worst case scenario, if we can't fix it, we can't fix it. So we'll start with this and go from there. Okay, so we've got the soldering iron heating up here. Just for reference, I'm going to show you again what pins we're going to try and heat up to pull this resistor out. We have one here and one right there. And that is our blown resistor. I did inspect over everything. I did not see any other obvious points of failure. I will say the factory that pushed this thing out really did a sloppy solder job. But I don't see anything that's like obviously cross-talking or anything. And until that resistor blew, ostensibly this thing was working. So I don't see that anybody else has been in here to try and do any repairs or anything. So I don't think it's like some prior shoddy repair work other than my own shoddy repair work. But I think at this point, this has almost got to be the issue. Now, to get my needle nose in here is a real hectic challenge. I don't know. Well, that might be enough. It's kind of hard to see, so I'm trying to look at it from sort of a reverse angle, but I'm hoping I'll have enough grip to get just enough of a touch to it that when it starts to loosen up, it should come out pretty easy. So our iron is hot. We're going to go ahead and get started. We'll start with the back contact. Give that a good heat. Coming out pretty well. I just don't want to burn off the solder pad. That's my big worry. Alright. I think we're going to just give it a quick second here. It's certainly coming free, so I think I did have a good grip on it with my needle nose. Let's see if we can't improve said grip. Try and get a round 2 on it here. Okay. Another grip on it. There's one side out. And with any luck, I should have second side out here shortly. There we go. I think we got it. I did see a very small piece of solder bubble off. I'm really hoping that didn't fall in anything critical. But it does look like I've got the resistor mostly out. You should be able to... There we go. All right. Let's go ahead and pull the rest of this crap out of here and take a look at what we've got. Okay. Well, on one hand, we've got the resistor off on one side for sure. On the other hand, it looks like it may still be stuck in there. Again, the access is really kind of the bear we're dealing with here. And I apologize, I have not moved the camera to give you guys a better look, but I'm trying to kind of get this out of here. Let's see here. You can kind of see it right down in there. Unfortunately, I don't have any finer needle nose pliers or an angled. Alright, well, I've got that at least. Yeah, that's still soldered in place. And it looks like I just broke the leg off right there. Which is not the end of the world. I mean, I can always just solder the resistor through. But really like a nice clean solder pad if I can. I'm going to try and get something else to kind of finagle this here. Let's see if we can't get a better grip on this. Let's play around. All right, I'm able to get a really nice grip on it now, and hoping that I'll have just enough play to get a little bit of heat on that pole. Oops. All right. I don't want that to happen. Okay, get our grip established here. Maybe first we find our solder pad. Alright, there's our solder pad right next to Q12 there. And then the back one's still got a chunk of that in there. The tough part is this plastic shield is just really in the way. I don't want to pull the whole thing out because I feel like it'd be a real bear to get out, and then to get it back in would be just another issue I don't want to have to deal with later. So try and clamp it off. Jump some of my soldering stand clamps here. And again, it doesn't have to be pretty, so I'm not worried about aesthetics. But I would really like it if it is functional again. So, all right next to Q12, we're going to go ahead and just hit it with a little heat and hope it just drops, I think. Alright, there's one side. And we'll see if the other side will drop as well. May have to try and use some solder wick just to soak up the excess. Alright. I think, unfortunately, we pulled one of the pads out, but I'm not too worried about that. I've dealt with that on other components. There we go. Here's our old resistor. And let's take a look and see. And we're going to use this little copper here to clean up our soldering iron. Just a little bit anyway. Try and get some of that excess solder that's built up on there off. Alright, good deal. So here is our resistor. Now it's been chewed up a little bit by my needle nose, but you can see that this was blown out because it's actually black and burnt there. And see where it's bare metal, that's where the needle nose was gripping it. I know the focus here isn't great, but I think that definitely supports that this is probably the bad resistor. Now the tough part is, since I've gnawed it up so much, figuring out exactly which resistor we need might be a little bit more difficult than I was anticipating. But it looks like we've got red, red, gold, and the rest of it I may have to zoom in on the video to try and figure out. So let's locate our correct resistor and see if we can get a good one soldered in place. Alright, so looking at the resistor up close, I did identify that this is a red, red, gold, gold, luckily a common resistor. So we're looking at 2.2 ohms, plus or minus 5%, quarter watt, and I've got 40 of them, so I don't think I'll be running out of these anytime soon. But this should be the proper resistor to replace the one we need. I do see, looking at the front of our PCB here, there's a little bit of solder left in there. But it looks like the solder pad is okay. I mean, worst case scenario, may have to finagle it a little bit, but if we have to finagle it, we have to finagle it. We do have to make sure that the orientation is correct. So that's really important, because you want to make sure your energy is flowing properly so the resistor provides resistance in the appropriate manner for your board. Okay, so the proper orientation is going to be reds on the bottom solder pad here by the R for R166, and the golds will be at the top. So just noting that, so basically if I need to go back and reference this when I'm putting it in place, I know where to go. Alright, so I did end up pulling out a solder pad, trying to get that lead that was broken off out of there. Sorry, the camera's not wanting to focus on it. So I'm hoping as I get this soldered back in place, there'll be enough contact to it. It's kind of a bummer, but hopefully there's enough. It's not a guarantee, of course, but we're going to give it a shot anyway. Okay, well, I've got one side of the resistor in place, so I'm going to try and solder that in, and then at least have that part of it done, because I can't seem to draw out the solder from the other side. So I'm hoping to be able to get just enough fresh solder on there. There we go. To keep one side going. And then we'll try and solder on the other side somehow. Again, the issue right now is the solder from the old resistor is basically stuck in place, and the solder wick won't draw it out. So I'm going to have to start to get creative here. As you can see, I've already melted this heat shield. I don't really care. It's just plastic. It's not really doing a whole lot other than making sure there's no contact with the chassis. and I'll throw some electrical tape over it and it'll be fine. All right, hopefully you can forgive the extreme zoom here. There's our resistor, and that's the very end of the lead. I'm really hoping that I can just basically touch this lead end and solder it in place, because honestly I don't know that I'm going to be able to poke it through. Properly, but I think that just connected. It's really quite terrible looking, but I mean, it isn't cross-talking with that little electrolytic next to it. Let's see if I can zoom out a little. I mean, it's not pretty, it's not clean, but it may be making enough contact to do the trick. I'm just gonna wiggle it with my screwdriver here just to see. Nope, not making contact. Alright, so let's go ahead and reheat it from this side. Okay. Alright, that was very ginger. I have a feeling it's just sitting in a ball at the bottom, and I tap this and it moves. Oh, maybe not. Well, I'll be damned. Alright, well, again, not pretty, but it's on there. And it is not touching that heat sink at all, which was the only other thing I was worried about. So what I'm going to do is I'm going to take a little bit of electrical tape and just kind of slide it on there, almost like a basically a heat shrink, and hope that that is enough just to prevent any accidental contact. And then I guess we just plug this in and see if it works. Alright, well, again, not pretty, but I got some electrical tape over that heatsink, which should prevent any kind of, well, basically shorting, hopefully. And just going to patch up that little piece of plastic there, and then we'll plug this in and see if my terrible job at putting a new resistor in actually worked. Alright, it's all back together. All that remains now is to plug it in to the case it was in and see if it draws any power. Okay, so we've got the power supply back in place in the original case it came out of. I've only hooked up the 24 and the 8-pin connector, which is only supplying power to the motherboard. At this point, I don't want to risk frying any of the hard drives or the optical drive or anything else in here. I just want to see if we're getting a draw from the board, which should at least kick on the fans here, to power supply and to the cooler, and of course the case fans. So I'm going to go ahead and get a power plug here. We're going to plug it in. If we don't see sparks, that's the first good sign, and if fans kick on, we know we've got a good power supply. All right, here we go. I'm going to start by giving this thing some power. All right, so far no sparks or anything. It's not switched on yet, but let's just see. All right. No sparks when I hit the switch. Let's go ahead and see if we can hit the power button. Oh, well, it helps if you turn on the power strip. All right, with that, now it begs the question, did I have the power button wired up? I got nothing there, nothing there. No action from the fans, so a couple of possibilities. Could be that the resistor was not our issue. Which is kind of a bummer. It could be that the resistor is not in place, which is a very strong possibility, actually. But yeah, at this point, we've got no action out of this power supply at all. So we'll have to crack it back open and check out our wiring job and just see if maybe that resistor was not in all the way or not making good contact. Alright, I just wanted to double check my connections and make sure that I actually had it plugged in all the way to the board. So haven't seen any action yet. Nope. Still no good. I do believe I'm hitting the right power buttons. Yeah, I see no action on the board at all. Okay, well, next step is to open it back up and take a look.